Hello friends, welcome back to the channel Maths Insider. So today's topic is about linear equations, types of solutions of pair of linear equations of two variable. Now what you will learn from this video. So if you remember, for the last videos we have learned about different methods of solving the linear equations. Now whether you can thought of that any pair of linear equation always have the solutions, the answer is no. So then we have to learn about these types of solutions of pair of linear equations, and in these types of solutions we'll see the different conditions, different graphical representations. The second thing is graphical representation of the types of solutions, where we'll see how we can able to interpret the different types of solutions. The third is mathematical conditions of the type of solutions. This will also give you the fair good idea of interpreting those equations without actually solving it. You can able to find whether the solution is there or not, and there will be some important exam tips. This is very important, and you can able to understand the concept. So please stick to this particular video till the end. Hope you will enjoy it. So let's get started. Now a pair of linear equations can be written as, so these are all standard forms or a general form. We can write it as a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. These are pair of linear equations. Now when we draw these equations on a graph, so we have already seen in graphical method, so each of this equation will represent a straight line. So for the linear pair of equation we will always get a straight line. That is the nature of the graph. Now this we have seen in the graphical methods. So in the graphical method we have touched upon this, but here we will learn each and every concept thoroughly. So we have already learned in this graphical method while we are solving this pair of linear equations. So what is that? So you can able to see we can form the two coordinates. That is, these are obviously two-dimensional, so we have only x-axis and y-axis, and then we can able to represent these two general equation as two straight line, and so they can take any form that depends on the values of a, b and c. So say for example I am representing the equation a1x plus b1y plus c equal to 0, and the second line we are represented at a2x plus b2y plus c2 equal to 0. So that is how we can able to draw the equations in the graph. Now the positions of these two lines will tell us how many solutions the equation have. So now on the basis of the position of this graph or of this line in the graph, we can able to see how many solutions are there. So there are only three possible cases. So we can able to derive three possible cases on the basis of the position of the line on the graph. So case 1, which we call as an unique solution. So we will try to interpret in the graph, and also we will see the mathematical conditions one by one. So if we draw two intersecting lines, so now if we draw means whatever equation will be given, if we represent those equation and it gives the intersecting lines, then what will going to happen? So when the two lines intersect at exactly one point, they have one common point. So when they're intersecting, they have only one common point. So what we'll get, this common point or the common point will gives one value of x and one value of y. So whenever the two line is intersecting in the graph, they have a common point, and that common point will give one value of x and one value of y. And the pair of equations has one unique solutions. So that means since it is giving one value of x and one value of y, so it will give the unique solution. There will be no second solution for that. So that is the nature. Let's see by taking an graph how it will look like. So we have two dimension Cartesian coordinate, x-axis and y-axis are given, and we are representing two lines and they are intersecting with each other at certain point, say P. So now here what we are doing, we are just again representing the general equation for the given two lines, and we find a point which is a common point where they meet. So we called it x1 and y1. So this P, which is a common point where the two lines intersect, that is P x1 y1, this gives the unique solution of the equations, of the pair of equations. Now this pair is called, a consistent and independent solution. So we'll get a consistent and we'll get an independent solution. Now let's take an example. X plus y equal to 5 and x minus 1 equal to 1. If we represent this two in a graph, so I'm just leaving to all of you to plot this and see it and verify it. So that will help you to again revise your graphical method of solving the equation. So these lines intersect at one point and their solution is x equal to 3 and y equal to 2. So we'll get a unique point or common point, and this will give us an unique solution. Now let's check the mathematical condition for this case 1 when the two line intersect with each other. So for the pair of equations a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, we have a1 by a2 is not equal to b1 by b2. So these two ratio should not be equal. So whenever these two ratio are different, then the equations have one unique solution. So that is simple. So whenever this ratio, so from these two given equations, if we find this ratio and if we see they are not equal, we can easily derive this is one unique solution. Now case 2, when there is no solution. So we have, in case 1 we have found one unique solution. Now case 2 is no solution. Now if there is two lines, suppose there are two lines, and if we draw those two lines to get two parallel lines in the graph, so then what would be the solution that we can able to derive from it? So let us draw those parallel lines in the graph. Again we are taking a two-dimensional graph and we are just drawing two parallel lines, and we can again we can represent this two line with the general equation as a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. Now what we can able to conclude from this graph? So we can notice that they never meet with each other. So as they are parallel, we know parallel lines will not meet with each other. So since there is no point of intersection between these two lines, so there is no point of intersection, we cannot see any point of intersection, so there is no common solution. So we will not get any solution there. there is no common point. So they have no point of intersection, and therefore we will not get any solution. So the pair of equation is called, so we are giving cross means inconsistent and they have no solution. So they are called inconsistent pair of equations. So let us take an example to see. So x plus y equal to 4 and 2x plus 2y equal to 10. Now if you again plot this 2, you will see these two lines will be parallel to each other. So they will be parallel to each other and there is no solution for this particular equation. Let's see the mathematical conditions for this case 2 where there is no solution. So what is the mathematical condition for this kind of this type of pair of equations? So it will be a1 by a2 equal to b1 by b2 not equal to c1 by c2. So here the coefficient of x and y should be proportional. They are proportional, but they should not be equal to or but the constant are different. So this is the main condition for the equation to be to have no solution or inconsistent. So for our pair of equations a1 by a2, so a1 equal to 1, a2 equal to 2, b1 equal to 1, b2 equal to 2 and c1 equal to 4 and c2 equal to 10. So let's calculate a1 by a2 which is half, b1 by b2 which is half, c1 by c2 is 4 by 10, that is 2 by 5. So what we conclude, a1 by e2 equal to b1 by b2 or they are proportional, but the c1 by c2 they are different. So the lines remain parallel forever and will not get any solution out of these equations. Easy. So case 3, now the third case, which is when the pair of equation will be having infinitely many solutions. Now we will see and interpret in the graph how they look like. Now draw only one line. So for the given equations, we take one equation and we draw one line, but actually there are two lines. So what we can able to see, both are exactly on top of each other. So that means they're overlapping. So they're the same line. So one is falling on the other. So let's see in the graph. So here what will happen, we are drawing one straight line in the graph and then on the top of that we are taking another straight line which is on the top of the blue line, as you can see. So we are differentiated by the color, but they are falling or they are exactly on the top of each other in this x-axis and y-axis. This is the, so we are just putting a1x plus b1y plus c1 as general equation and a2x plus b2y plus c2. So from this graph we can see that overlap completely. So two graphs overlap completely. So this means that every points on the line satisfied both the equations. So whatever point we'll take in this graph on the line, it will satisfy both the equations. So this line overlap with one another and every points on these lines will satisfy the equations. So So therefore what we can see, there are infinite or infinitely many solutions for this pair of equations. So this pair is called consistent and dependent solutions, because the value of y will be completely dependent on x. Take an example, x plus y equal to 3 and 2x plus 2y equal to 6. And what we can see, the second equation is simply twice the first equation. Now we can see that both the equations represent the same line on the graph. Now mathematical conditions for this case. So what is the mathematical condition for case number 3? So the mathematical condition is a1 by a2 equal to b1 by b2 equal to c1 by c2 for all the coefficient and constants of the equation. So when all the three ratios are equal, so when all the three ratios are equal, we can say that they are consistent and will generate infinite many solutions. Now memory trick. So simple trick to remember the conditions of the pair of linear equations. So case 1, what we can do, the first two ratios are different. That is, a1 by a2 is not equal to b1 by b2. So this is different. So how you can represent in graph? The line meets at a point. And what a kind of solution we'll get? One solution that is a unique solution. Now case 2, what we'll get? The first two ratios are equal or proportion. The third ratios is different. So that means a1 by a2 is equal to b1 by b2, not equal to c1 by c2. So what about the line representation? Lines are parallel to each other and there will be no solution. Case 3, so here all the three ratios are same or are equal. That is, a1 by a2 equal to b1 by b2 equal to c1 by c2. That means the line overlap with each other. That means there are infinite solution and they are consistent and they're dependent. There are many solutions. So if we can able to keep this thing in mind in the form of tabular form, it will be easy to remember and you can able to find the solution just by looking at the nature of the equations. I hope you can able to summarize this in this tabular form and can able to implement while solving the problem. Now let us solve an example. So what we have, we are taking two equation 2x plus 3y equal minus 5 equal to 0 and 4x plus 6y minus 10 equal to 0. So here a1 is equal to 2, a2 equal to 4, b1 equal to 3, b2 equal to 6 and c1 equal to minus 5, c2 equal to minus 10. Let's calculate the ratio. So we are using the mathematical conditions. So a1 by a2 equal to 2 by 4, which is half, b1 by b2 equal to 3 by 6, which is equal to half, so they are proportion, and c1 by c2 equal to minus 5 by minus 10, which is again half. So what we can able to conclude? So we can conclude that it is falling under case 3. So all the ratios are equal, so line overlap and there will be infinite solution. So see how if you can able to keep this table in mind, you can easily solve this kind of problem. So here a1 by a2 equal to b1 by b2 equal to c1 by c2. So this is case 3 So lines overlap with each other in the graph, and this will provide infinite many solutions. Now, some important exam tips that the students should keep in mind. So, what are don'ts we should follow? So, forgetting the negative sign with c, with the constant c, that we should have to keep in mind in the equations. Then this comparing the wrong coefficients. Comparing the wrong coefficients will generate the wrong interpretations. So we should keep that thing in mind carefully. And memorizing the condition without understanding the graph will also leads you to wrong interpretations. So we should understand the graph and the mathematical condition together. That will really help you out to solve this kind of problem. So always draw a quick sketch in your notebook, and it will help you remember the concept much better. So sketch, that is the table that I have already shown you. If you can draw it every time, it will help you to memorize. Now quick revision what we have learned so far. Number 1, the 3 position or types of solution, then the meaning of consistence, inconsistence, and the dependent solutions for the given equations. Then what we have learned, the 3 ratio of the conditions, that is mathematical conditions that we have learned, and how to identify the number of solutions, that is how to identify the type of solution without actually solving the problems or the equations, given equations. So I hope you have enjoyed this video and you have learned the concept. So in the next video we will going to learn on different problems, that is we'll take different word problems on pair of linear equation, and we will implement different methods to solve it. If you like it, please share with your friends and subscribe. So see you in the next video. Thank you.